This is an image of the Schrödinger impact basin on the lunar surface, way down at the moon's south pole. Sprouting from the enormous crater are two canyons, each as deep as the Grand Canyon here on Earth. Now, new analysis has revealed details about how these enormous chasms were carved out of the moon's surface. And they say it could have happened in less than 10 minutes. Stretching across 320 kilometers, the Schrödinger basin was formed some 3.8 billion years ago when a meteorite or comet smashed into the moon. The impact site is surrounded by a blanket of material ejected from the crater, and cutting through the surface are two canyons, called Vallis Schrödinger and Vallis Planck. Vallis Schrödinger and Vallis Planck are huge. Both are nearly 300 kilometers long and around 2.7 and 3.5 kilometers deep. But unlike Earth's Grand Canyon, which was formed by water slowly eroding the rock over 5 or 6 million years, this analysis suggests these lunar gulfs were excavated in just minutes. These chasms are called rays, and they were formed by material thrown up when an object collided with the moon. Huge pieces of high-energy debris rained down after the initial collision, their tight pattern forming rows of craters that created these deep canyons. Analysis of the shape and position of these valleys can tell researchers a lot about how they were formed, and also give clues as to the trajectory of the original impact. Vallis Schrödinger and Vallis Planck don't converge to the centre of the Schrödinger basin. Instead, they meet here, at 78.2 degrees south, 143.7 degrees east. That might mean that whatever hit the moon made its first contact at this point, and the team can estimate its trajectory along this line. Other trajectories are possible, but they all suggest an impact ejecting material away from the South Pole. And that's important, because soon NASA's Artemis missions will be exploring this very area. Knowing what material is like to be scattered over the lunar landscape at the proposed landing site is vitally important if the robots and astronauts on the missions are going to be able to retrieve the samples they need.